So friends, in this video, we'll simply discuss about that simple introductions of the neural network and what is the motivations behind it and what is the history that we are going to discuss for that one. So this is the first introductory level with introductory lectures, and as we progress, then we will move further. So, so in this lecture, mainly I have discussed about that what are the history that the AI comes into the pictures and what are the main development of neural network through the help of the human structure. So here first the concept of the perceptron, that's we call the develop the neural network, but the primary concept, basic concept of the thing of the neural network, it's the perceptron. Perceptron. It comes into the pictures in the year 1957 through the mathematician's name. The mathematician's name is that I think Rosenbach, and is a mathematics guy. He's actually first try to try to introduce that concept of the neuron that is the perceptron. So, how these concepts come into the picture first? Let's try to understand it. So, this is that if you just go through some neuroscience book or some biological book, you will see that this is the structure of the simple neurons. So, the structures is look like this. Here is that the dendrites, this is the cell body, this is the axons, and this is the some terminal axons. So, here, so if you just think technically, so in this portions, so yes, in this portions, it takes some input. In this through this portion, it takes some input, and some operations are organized in that cell body, and after that, they have give the output through that terminal axons. Through that, give the output. Now, the question is, this is the simplest structure of the neuron. It's not an actually like one. I'm not a biological guy. There have the lots of things are involved here, but the operations how it's work, that's the main thing that we have to understand. And now anyhow how we'll convert that thing in some form of a mathematical structures, that's the main challenging part here. So this is the first working structure is here, give take some input as a electrical signals, and some operations are happening on that particular cell body, and after making that operations, it will passes that output through that transactions. That's the simple. Now the question is, this is the simple one, and this is that some complicated one. That is that how the many more neurons are connected is that we will come into that later part. So the first thing is how we'll convert the thing, how that convert that concept in the form of a neuron. Okay, that's the main challenging part. So in that using that thing, actually using that concept, using this working concept of a neuron, the mathematician Rosenwald introduced that simplest mathematical form of a neuron that we call the perceptron. This is the simplest form. So what happening actually here? So here we have put some input, give some input like x1 is a one input, x2 like that. It's an input. We'll pass through that one, and after that they are have for age drain, right? They are have the length of the, that is the weight, means that if you just the density of the drain, right, is not the same, it's a different one. So here the main concepts come into the picture. This is the may have the major roles to take decisions in human one. So here the weight, the weight of that dendrites is denoted here, that some variable like w1. Now the main challenging task is how we'll decide in which input what will be the weighted value. That's the main challenging one. So to reduce that one, I will discuss as we progress. This is the first introduction level lecture. As we progress, we will discuss the concept how we will decide that weight value. So here first we will take in an input, and first suppose as an example we have taken that the input one. Suppose I have put it input one. This is like input two. This is like input n. Sorry, input n. So and for input one, that let's take w1 is the weight value, w2 is the weight value for input 2, and wn is the weight value for the input n. So first of all we have to make that the the summations of age input to that one means that I am want to use here x1 w1 plus x2 w2 and like that xn wn. So mainly we will make that operations first. So after that, after making that summed value means the multiplicative sum, you can think multiplicative sum value, we will pass that value through n functions. That's called an activation function. Activation functions, and after that activation functions, we will decide what will give that output, and these things called that output of that. This is the input, and after making that input, we have to give some weightage value for age input. Now the questions is, after taking that multiplicative sums of age input and weighted value, we have put here some activation functions. Now here three things you can observe here. Three things I have written here. So first one is that input value. Yes, it's obviously in our, it comes from our datasets as you think, as classical one. Now second challenging part one is the weight value that we call wi, weight value. So in the deep learning, in the subject of deep learning, main challenging one, how we'll decide what will be the correct weight for age input. That's the main challenging part. Okay, if we solve that issue, so 99.99 problem percentage problem is solved. So it's not, it's just to discuss here, it's a single neuron, but in real deep learning scenario, it's not a single neuron, it's a lots of neuron together. But for age neuron, how we'll decide what will be the weight, we'll discuss everything, just be patient. Okay, this is the first one. This is the second challenging part, how we'll decide that weight value. The third challenging part, it is the easy one, multiplicative sum, simple matrix. If you just learn through the linear algebra, then how we'll make the matrix multiplication. This is the simple. Sure, this is the sample sum. So multiplications. Now fourth one is that concept of the activation function. So there have lots of activation functions like sigmoidal, ReLU, like that. As we progress, we will see how to make that active, how to use in which situations, what kind of activation functions we have to use. We will see that kind of things. So activation function. Now fifth part is that corresponding output, and there have lots of things, drop out, softmax layer, everything. As progress, we will see one by one layer, we will clear one by one layer. But this is the simplex structure of a perceptron. Okay, and these concepts come from a simple neuron. Now the question is, it's a simple neuron, but how will connected is neuron? Suppose in human body there are no, they're not a single neuron. There are lots of millions, billions, in billions of neurons are connected each other. But how we will make that simple mathematical concepts in that particular way? So here the concepts come into the picture is that uh, um, the multi-layer perceptron, MLP, multi-layer perceptrons comes into the picture. Sure. So multi-layer perceptrons is what? Suppose A's neuron is connected to the other neuron through that weighted value. So here you can think. Suppose here is a one neuron. Some input is coming from here this side, and some operations that I will discuss are organizing on the node. So similarly, it's through that output. It's through this output to the neuron. It's through this output. Similarly here, this is that one multi-layer perceptron. So these things are called that input layer. Input layer. These things are called the hidden layer, and this is the output layer. This is the simplest structure of the multi-layer perceptron. Now the question is for a neuron, how will you compute that weighted value for multiple neuron? For MLP, how will compute the weighted value? How will compute it? It's things in depthly will analyze the things through mathematical way as well as through that coding, through using the Python programming language. You will see how will visualize this thing, how will compute that thing. So you will each thing we will discuss everything, but be patient with me. Now the thing is that that what is that related to the neuron to the human. So these pictures I have taken from these two pictures, actually I am taking from the Google image. Just equal type will Google, you know, like that kind of things. And the multi-layer perceptrons versus the human neuron versus that the artificial neuron. then you will got that kind of pictures. And also one picture I'm going to show you. So this picture, if you see, in the pictures, this is that the various ages and the density of the neurons. So the mainly the density of the neuron is that dependent on the connections between the neurons. Okay, so the connections are the connections, if the, lots of connection means, then the density is increased. So if you see the at the age of that 1 plus means the instant birth on that particular age, they have that nothing connected here, means that they have no learning process or that for a instant birth child. But when the childs grow, they try to analyze things, they try to learn something. So as you can see, so there have some little bit density occur, some little bit connections occur between the neurons. Then you can see here some little bit connections occur when at teenage age they have something progress to the learning process, they will progress. Sure, they have the density, the connections also increased on that particular, on the particular particular on the particular connections. Okay, particular neurons. And similarly, when age grounds, the left brains and the left brain, this is that. Actually, I am not a neuron scientist, so I am not going to discuss everything. So if you're interested, then you can search on. There have lots of research paper and available on internet. Then you can search it. So this is that one that age between the 30 to 60. This is the structure of the density of that neurons. So on that particular age, we have that peak age in the adult peak age. So the maximum number of density as we have seen on that particular age groups. Okay, and as age progress, so at the age of 65 plus, then you can see we will think to, we'll forget something like that. So on that particular age, the similar way connections are losing. So and similarly 70 plus and the age of that no neurons are there 80 plus when before death I am talking about. So that's that simple when we born and when we go through that world, this is the simple structure. So this is the main peak age, you can think. Here lots of things happen, lots of discovery, lots of, in that particular age we will discuss lots of thinking, lots of things. So on that particular age too, these are the density of the neurons. So as so this is the simple conclusions here we can make from these pictures here. When we when our learning process growing, then our connections between the neurons are growing. That's the simple thing here. From that research we will analyze that things. If our learning process is growing, then the connections between the neurons are growing. So here connections between the neuron means what? You can think in mathematical model, connections between neuron means this weight value. Suppose its weight value, if we consider the weight value scale between the 0 to 1, the scale weight value scale is between 0 to 1. So if they are have the some weight value 0 means that there are now no connections is there. If they are have that totally dependent each other, so here 1 means the connections between two neurons are, means that they are dependent each other very huge amount. So if 0.5, so this value between 0 to 1, these value are depend on the thickness of that dendrites, that you can think as mathematical way. Okay, I think you will understand something little about that how these things come into the pictures and what are the related things, the human structure to that artificial neurons. I think you'll understand something little bit. Now let's come to that part of that history. What are the, so this is the simple motivations that I'm talking about. Now let's talk about that history part. What are the history of discovering this kind of thing? So first, the in as we discussed in first 1957, Rosenberg developed actually introduced this concept. Now the main thing here in 1986, the one applied mathematicians like Hiltons and other guys actually developed that concept of the back propagations. And to decide this as we progress, we will see how much important this backpropagation concept is. So to decide the what will be the weight value for each input and corresponding the output, so this concept backpropagation concept has lots of meaning. So in the next few series, next few lecture, we will see how backpropagation works actually internally works, so we'll see that things. So this is the backpropagation. Back propagations it's introduced, so it's totally different. These back propagations actually, if we see the mathematical way, mathematically back propagations actually internally use that simple multiplication chain rule. In 12th standard we will see the calculus chain rule. The simple chain rules are using here, but in some complicated way they are have not a single chain rules. They have lots of chain rules, lots of connections are there. We'll see that things, don't be hesitant. So but the main thing that the complicated one on the particular age, when they introduce that concept of back propagations, that they have not such computation power on that particular era. Means that I'm talking about the 1990s 1986, not we have not such amount of computational power. So for that reasons, this concept is not so much popular on that particular age. But uh, but uh, the things comes into the pictures. You can think like a 2012, this is the main era of the deep learning. So why actually on that particular age there have some data sets like image nets competitions are there, I think. Yes, image nets competitions are there. So for that image nets there have lots of data and some computationals also power that are available on that particular on that particular year. So on that particular year in 2012, so there have for the challenges and the other mathematical guy other means the traditional machine learning concepts are using simple SVM, like GVDT, like random forest techniques to solve that problem in an ImageNet problem. So I think all you know about the ImageNet. Or ImageNet means that there have some billions, millions of the image, and they are at the some level of the day's image. Now we have to identify. I have to make some algorithm. You have to make some model that you identify that what image will be there. Sure, but the in 2012, so using the deep learning concept. Mainly deep learning means I'm talking about that multi-layer perceptrons concept. They have they have discovered a huge amount. They have discovered a huge 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 amount of effectiveness results for that particular data sets. So this is the main one. So because why these things happen? So deep learning concepts are occurring. You can see 1986 through the back propagations, but it gives successes in 2012. What is the main reasons behind it? So the first reasons is that the availability of data sets. There have the huge amount of, so I think 1 million image are there. 1 million, yeah, greater than 1 million, you can think. Greater than 1 million images there. So first thing is concept is the data sets. Lots of data sets are available there on that particular one, on that particular age. And also second thing, important thing, computation power. Computation power. These two, because of these two things, this give that so huge proper results that we can believe. Okay. So this is the main era, in the main starting era of the deep learning. So, but today's why the deep learning concepts is most popular. Why this concept is so popular in that particular age. So because first reasons we have today in the today we have lots of computational power. First thing, lots of computational power, huge amount of computation power, huge computation power we have. And second thing is that we have lots of data, because this internet age we have billion petabyte of data. We are sitting on the petabyte of data. So that's one thing. Lots of data we have. Okay. So this is the two main reasons we can think the why the in today age artificial age why deep learning is so popular. This is the two main reasons for deep learning. And also one thing I have to add here, that some brilliant concept, brilliant new algorithms. That's not an main issue. But as time progresses, we will also face that some new learning technique. But the main thing is here, we in that particular age we have lots of computation power and lots of data. For that two main reasons, we have deep learning. It's so popular in today also. Okay, so I think on that particular video for that history and some motivations, I think you'll understand so why we need. And as time progresses, we will discuss what are the mathematical concepts, how it's work, how it will apply to the real world industry, and also you will see the things through that Python code. And in next video, we will see what are the applications, some interesting applications of that deep learning. We'll say that in next video. Till then, bye.